Welcome and thank you for standing by. At this time, all participants are in a listen-only mode into the question and answer session of today's call. At that time, if you would like to ask a question, you may do so by pressing star 1. Today's meeting is also being recorded. If you have any objections, you may disconnect at this time. I now would like to turn the meeting over to Ms. Sandra Loy. You may begin.
Great. Thank you so much. Welcome, everyone, to a Clean Cities webinar this afternoon. Hope everyone is doing well. Today's webinar is Alternative Fuel Vehicle, or AFV, Air Pollutant Emissions focused. So today we have Andrew Burnham from Argonne National Lab, and he's part of the Clean Cities team there. He'll lead this webinar today, and we'll discuss issues related to the air pollutant emissions from alternative fuel and advanced vehicles. He'll also discuss how various AFVs, or alternative fuel vehicles, differ from conventional vehicles and how this has changed due to recent regulations. So welcome again. Thank you for joining us today. We will have a Q&A at the end of Andrew's presentation, and we also will be posting the PowerPoint as well as the recording on our Clean Cities webinar archives pages, so be sure to take a look at that. We host these Clean Cities webinars on a monthly basis. We sometimes have more than one per month, so thank you for those who might be stakeholders and not as familiar with the series, and we appreciate you being here. I'm going to go ahead and introduce our speaker and then let him go ahead and get started on his presentation. So Andrew Burnham is an assistant environmental scientist at Argonne National Laboratory. Again, as I mentioned, he's part of our Clean Cities team, where he has worked since 2004. At Argonne, he develops tools and provides technical analysis regarding the environmental and economic impacts of alternative fuel and advanced vehicles for the Department of Energy's Clean Cities program. In addition, he performs life cycle analysis to help update the greenhouse gases, regulated emissions, and energy use in transportation, or the GREET model. So, Andy, I'll go ahead and let you get started. You may begin.
All right. Thank you very much, Sandra, and thank you, everyone, for joining in on this webinar. So today I'm going to talk about alternative fuel vehicles, conventional vehicles, and air pollutant emissions in general. First, I'm going to give you a little outline of my presentation. I'll first start talking about air pollutant emissions in general and the A-Fleet tool, which we developed for Clean Cities to look at these emissions as well as some other environmental and cost indicators of alternative fuel vehicles. The next, I'll talk about some trends on air pollutants and the larger trends in the U.S., and then dig into motor vehicles. Then I'll get into some specifics on heavy-duty diesel versus alternative fuel vehicle emissions, and then finally I'll touch a little bit on light-duty gasoline versus AFCs as well. So first thing I wanted to talk about when we talk about air pollutant emissions is, well, what are they? There's a wide range of air pollutant emissions, and vehicles can have several that are important for the emissions from them. So first, I want to start off discussing each of some of the key emissions. So one is carbon monoxide. So at low levels, it can exacerbate cardiovascular disease. It basically reduces oxygen delivery. At high levels, it can be very poisonous. Particulate matter is something that can cause some serious health effects impacting the lungs and heart. Really, the health impacts depend on the size. So fine particulates, which are typically called PM 2.5, cause more damage than larger particulate matter. You'll often hear about PM 10 as well. Nitrogen oxides cause various environmental problems, but the primary concern is ozone. Volatile organic compounds have kind of the similar concerns. They have various environmental issues and health risks, but the primary concern when we're talking about vehicles is its impact on ozone. And VOCs can be called actually a lot of different things, and there's kind of different groups depending on which chemical it is. For light-duty vehicles, it's regulated as non-methane or organic gases, and then for heavy-duty vehicles, it's non-methane hydrocarbons. So there's a lot of alphabet soup with these air pollutant emissions, but this is hopefully a good way to get some of these things straight. And then finally, as I was talking about ozone, which isn't a direct emission from vehicles. It's actually produced from a reaction of NOx, VOCs, and sunlight. This can cause really serious health effects, impacting the lungs and heart. Asthma is, a big concern, as well as other key issues. So really, the regulatory focus on vehicles has primarily been on particulate matter and ozone, because those are the most widespread and biggest concerns relating human health. So getting back to what we have done in this area, Argonne has supported Department of Energy's Clean Cities with various tools for the past 15 years. And in that time, we've been looking at air pollutant emissions as well as other emissions and environmental and petroleum use and other things like that. So the first tool that we developed was AirCred, which estimated ozone precursor and carbon monoxide emission credits from alternative fuel vehicles for state implementation plans. That tool was around for about a decade. The next tool that we worked on was just basically a tool for the Recovery Act grants to look at greenhouse gas emission and air pollutant emission benefits for those grant proposals. And then most recently, we released the A-Fleet tool, which estimates cost of ownership, petroleum use, greenhouse gas emission, and air pollutant emissions of light and heavy-duty vehicles. The tool is available on the Argonne's GREET website as well as the AFDC if you haven't downloaded it already. So digging into what A-Fleet does relating to air pollutant emissions, it really is based off AirCred, which we used for a long time. So AirCred was a Department of Energy and EPA co-sponsored tool, and it was developed using EPA's mobile model, which is a model that calculates the emissions of different types of vehicles, light duty and heavy duty. It's a computer program. And then we also use annual emission vehicle and engine certification data to examine the relative impacts of alternative fuels and conventional counterparts like gasoline and diesel. EPA is typically solely focused on gasoline and diesel, or historically have been. That's their charge is to really focus on the big emitters, so that's what they have focused on. But we do have data on alternative fuel vehicles and can, make some assumptions to try and calculate, and that's what we did with AirCred. So we followed that approach with A-Fleet, but we now use EPA's MOVES model for gasoline and diesel emissions. And so the MOVES model really updated what Mobile did. It just basically improved the ability to estimate air pollutant emissions and showed really that the NOx and PM emissions from vehicles were actually much higher than the previous estimates that Mobile has done. And then as part of this process, we kind of went through the various fuel associations to send them, what we had done and show them, try to get some, peer review on the tool. So that was an important part of this process. And we plan to continue to update the tool. So Argonne researchers have been examining the latest work related to heavy-duty vehicle emissions. So that work is ongoing, but findings from that will be implemented into A-Fleet once that is finished. Now I'm going to talk about some air pollutant trends. One of the, big goals of, the Clean Air Act has been to reduce, air pollutant emissions, improve the human health impacts of breathing air. And so we can see in this chart from 1980 to 2013, the ozone air quality has, actually improved. The amount of ozone in the air has decreased about 33%. So there's been significant improvements. For a long time, a lot of counties were in non-attainment. Just recently, it's been pushed that there's been much less than there has been in the past. So that's the good news. Here's a chart from EPA that I think is an interesting kind of broad look of emissions and the economy and all these things, because there's a lot of things that go on that it can impact air pollutant emissions. We have the technology of the vehicles, how many vehicles are out there, how many miles do they run, and then we can also think about other emission sources like power plants and industrial and manufacturing. And so some of those things have changed where, it might been offshore or things like that, but we do still see that, emissions just in general, this is total emissions, have decreased about 60% since 1980. So there's been, significant improvement, and vehicles have been a big part of that. One of the other indicators that we see is that vehicle miles traveled have increased, pretty significantly since 1980. It's flattened out recently, but, we still have seen emission reductions. So I want to talk a little bit about that. So the previous chart had air pollutant emissions kind of combined together, and that's really not a good way to look at emissions. You want to look at them individually because they all have different impacts. So in this chart, we can see what percentage of motor vehicle emissions account for the total emissions from the U.S. And so we can see that carbon monoxide is primarily from light-duty vehicles. This is the red bars. The blue is heavy-duty vehicles. So it's a major emission from light-duty vehicles, carbon monoxide. For NOx, it's actually equally a big source from heavy-duty as well as from light-duty. Particulate matter is lower than a lot of other sources, but it's important because of the proximity of the emissions to the public. So that's why there's a big concern there for vehicles. And then similarly, there's a larger VOC emissions from light-duty vehicles. So that gives you a little broad scope of what motor vehicle emissions are in relation to other sources. So the regulatory focus has been on ozone and NOx specifically, as NOx typically drives ozone emissions. VOCs can drive it in some cases, but typically it's been NOx that people are focused on, and then also particulate matter. And the reason being is that 135 million people live in ozone non-attainment areas today, so that's a significant portion of the U.S. population. And you can see, obviously, large regions of California are in non-attainment, but also, other areas in the country with major populace are in non-attainment areas. So, it's a significant concern nationwide. And then when we look at PM, about 63 million people are in PM 2.5 non-attainment areas. So a lot of the same regions, but, a little bit less. Again, big concerns in California as well as the Northeast. One air pollutant that isn't necessarily a major concern today is carbon monoxide. So there's no counties, no population that is in non-attainment for carbon monoxide. So we've done, a relatively good job at reducing those emissions. So, regulations going forward typically have been pushing the PM and NOx. And we can see that really in some of the regulations for heavy-duty vehicles as well as light-duty. So in this chart, we see that the heavy-duty NOx and PM standards have been reduced by about 98% since 1988. So really made really significant progress and have pushed heavy-duty engines to be much, much cleaner than they were, only 20, 25 years ago. To do so, to get to these very low levels, it's required heavy-duty vehicle engine manufacturers and vehicle systems to really implement engine controls such as engine controls and after-treatment equipment such as diesel particulate filters for particulate matter and selective catalytic reduction for NOx, and it's typically called SCR, and that's where you would use a diesel exhaust fluid in a diesel vehicle to reduce the NOx emissions. Now, here's a chart of heavy-duty vehicles emission standards, and we can see in this top line here that really CO hasn't been a major focus for heavy-duty vehicles. One, they're kind of a small contributor, so there hasn't been a lot of regulatory focus there, but the big reductions have been for NOx here, and then for PM as well. They've been reduced significantly. Looking at light duty, we see similar trends. The carbon monoxide hasn't really been a huge focus, even for light duty vehicles, which are, kind of the primary concern for the emissions, just because, we're not in really non-attainment status in the U.S. for it. And the focus really has been on, again, on NOx emissions as well as PM. The CO standard kind of looks weird, that why would they let the standard actually jump up? But really the changes have been to account for longer time frames of the vehicle. So jumping from Tier 0 to Tier 1 standards, they wanted to make sure that the vehicle's emissions were good for longer periods of time, because vehicles are now lasting much longer than they used to. And so that's kind of an important, factor to think about when we're talking about emissions, especially on gasoline and diesel, that these vehicles are lasting a long time. So there's concerns with deterioration of their emissions, that they can get much worse as they get older. And that's where, alternative fuel vehicles may have some benefits, because they don't necessarily need to have certain after-treatment equipment that may fail in gasoline and diesel. So that's something to think about. With the standards tightening, one of the interesting aspects of understanding, like, where do air pollutant emissions come from, is to realize that vehicles don't act all the same. They drive differently, and there can be concerns with gross emitters, where a vehicle may not be operating like it should be. And in this chart, what we see is that for light-duty vehicles, for several different pollutants, 10% of the vehicles account for 80, 90, nearly 100% of different pollution. So it's a very small percentage of light-duty cars that cause a lot of the pollution. So, there's been efforts to reduce emissions from vehicles by inspection and maintenance programs. So in your state, you might have to go and get your vehicle tested. That's the reason why, is to make sure you're not a gross emitter. And if you are, then you're supposed to go get the vehicle fixed so it doesn't have those concerns. When we look at heavy duty, it's actually, somewhat different, that basically there's no clear trend that, there's a significant amount of vehicles causing a lot of the emissions. And this is just for NOx, but, that's the general trend, is that heavy-duty vehicles, we're not seeing as many gross emitters. For light-duty, we do see that. So some of the ways that, other ways other than inspection and maintenance to try and address that is to, as I talked about a little bit, is the certification standards are trying to make sure that there's onboard diagnostics and there's the ability to really analyze, how long the after treatment and emission control will last for, and try to push the automakers to guarantee that those equipment won't fail, and if it does fail, give the user some type of a warning that you need to go get your vehicle checked. So with those kind of factors together, the tightening of emission standards, the pushing of increased onboard diagnostics and inspection and maintenance, we have seen a reduction in emissions. So what this chart actually shows is that really there's turnover of older vehicles, and those vehicles typically are vehicles that were built under less strict emission standards. So as we go from the 1990, where pretty much all the there's a significant amount of vehicles under Tier 0 standards, which was basically like the initial standards and very high emissions. At some point we got rid of those, and next was Tier 1. And so, 2001, a significant, portion of vehicles were Tier 1, and now today, a significant portion of the vehicles are Tier 2. So that's kind of the progress that has been made to reduce emissions, at least from gasoline and diesel. So where are we today, kind of comparing, let's say, a decade ago of the emissions from light-duty and heavy-duty vehicles? So we've seen VMT kind of plateau. It's, in the last 10 years, it's, maybe 5% higher than it was in 2002, but vehicle emissions have dropped, between 40 to 50%, depending on the pollutant. So significant progress has been made, but, there's still work that needs to be done. And next, I'm going to talk about heavy-duty diesel and alternative vehicle emissions. So kind of as demonstrated, these stricter regulations have resulted in significant improvements in diesel emissions. So what we have in this chart is kind of the testing of different emission standard vehicles. So we have a 1998 vehicle, a 2007 vehicle, and a 2010. So each of these are under different emission standards. And as you kind of go left from right, you see basically the diesel emissions, and these are for transit buses, have gotten significantly lower than they were, compared to the 1998 and sometimes the 2007 vehicle for carbon monoxide, for hydrocarbons or VOC. NOx is significantly reduced, kind of in a stepwise manner, and then PM, again, very significant reductions in diesel emissions. Now, looking at fuel effects, when we talk about, well, what about alternative fuel vehicles? One of the big concerns when people were trying to implement biodiesel was the concern that it would increase NOx. And so now that we've moved to the 2010 emission standards where diesel vehicles pretty much all need to use SCR to control NOx, we've seen that the emission control technologies have really overshadowed the fuel effects for biodiesel. That here are the two diesel tests on the left, and then here are some of the biodiesel tests, and we really don't see much difference at all. There's a little variation between the fuels, but in general, the SCR technology has taken care of that. So biodiesel doesn't have really higher emissions or lower emissions. You can basically consider them pretty similar. Now, when we look at particulate matter, let's compare diesel and natural gas engines. Both have, made great progress. So in this first chart, we look at certification data, and we see the heavy-duty diesel actually was above the standard when it was released in 1996, and the heavy-duty natural gas was significantly below. And so, there's significant reductions, for the natural gas engine. Now today, the engines are getting certified at nearly zero emissions. So, under the testing procedures, there's really no difference between a natural gas and a heavy-duty diesel. So that's kind of really showed that, the standards have really pushed emissions down for diesel, and, you might not see, alternative fuel vehicles showing any benefits, for certain pollutants. And when we look at in-use testing, you can get some different results because there's, the standard on the certification where they, test it one way, but if you test the vehicles while they're being used, you can get different results. But actually, California has done recent testing and shown that these diesel vehicles with particulate filters have really just, nearly reduced the particulate emissions down to zero. So they've really made some great progress. As part of this California testing, they've done some comparisons of alternative fuel vehicles, so I'll be talking about that in a little bit as well. So we've seen the similar certification improvements for NOx. Here again is the 1996 Cummins engine, and they had the diesel and natural gas version. We see the natural gas version having significantly lower emissions, and here in 2013, the standards have tightened significantly. There is still some, small benefit, but kind of on an absolute basis, it's pretty small. It's only 0.1 grams, and, even though it's 50% lower compared to the older engine technology, which was only 33% lower, but had, a much bigger absolute value. So when we look at in-use testing of diesel engines, it shows that there still needs to be progress made. So California tested some vehicles with the SCR systems, and what they found was that the vehicles were not always meeting the emission standards, basically, and so they are concerned that SCR performance in the real world isn't the same as it is on a certification test. So some of the things in the real world that concern people about diesel SCR is cold starts, kind of operating conditions that won't get the SCR to work properly, and then deterioration of the after-treatment equipment as well. So I have a couple more slides on this because it's an interesting area, and it's really where the regulatory focus is. So what the testing has shown is that SCR is highly effective at highway speeds, but there's a big potential for off-cycle emissions. So where we see, basically this is a chart that shows diesel hybrids, and natural gas vehicles. All the vehicles show very, very low emissions at highway speeds, 40, 50 miles per hour. The after-treatment equipment on diesel works fine, and natural gas, is low in general. But once we get into some of these lower speed driving conditions where you have lots of stop and go potentially, or you're just starting the vehicle and it's warming up, there's potential for diesel, higher emissions. So, that's concerning to, the air pollutant and air emission regulators because of, the potential that even though the certification data shows very low emissions, you don't actually see them in the real world. And for natural gas, we're actually seeing, these little triangles show that they actually operate pretty well even at these lower speeds and lower stop and go driving. So that's been an interesting, recent testing result. So what we've seen is California look at kind of some different scenarios of driving natural gas drayage trucks or port trucks in different duty cycles. So they looked at a near dock situation, near the port, local delivery, and then something farther, regional haul where you're driving, on the highway. And what they found was that the diesel emissions were significantly higher in these near dock or port operations. They were slightly lower in the local, operations, more stop and go, and then regional, they're pretty low. But when we compare them to the spark-ignited natural gas or the HPDI natural gas, they're significantly higher, and then especially as you get more to these port-type driving cycles, the emissions are very, very high. So the natural gas trucks don't, exhibit this kind of concern because they don't use SCR. And so this is, again, a big concern, especially in California, for those who are interested in making sure ozone emissions are very low. Now moving on to a different pollutant, carbon monoxide. So I get a lot of questions when we do, A-fleet analysis is that, strangely enough, that natural gas isn't always cleaner, and alternative fuel vehicles aren't always going to be cleaner. And this really can, be a good example is carbon monoxide. So spark-ignited heavy-duty natural gas engines historically have had higher carbon monoxide emissions, and then even today their emissions are much higher. The reason why is that diesel engines use a different type of combustion called lean burn. And so what lean burn means is that there's just more oxygen available to oxidize carbon monoxide into CO2. Spark-ignited natural gas engines use a different type of combustion. It's called stoichiometric. There's less oxygen available, and thus it has higher emissions. They're all under the standard, which we see here, and significantly so. It's just, without, significant push from regulators to maybe add some after treatment or anything like that. The vehicle manufacturers and engine manufacturers for alternative fuel vehicles, might just feel comfortable with where they are without, wanting to add a lot of expensive equipment to that. Now, looking at propane vehicles, there hasn't been a lot of tests of heavy-duty propane, but a recent analysis, kind of as part of this California study, there's been a little bit of work on that, and so, and then the other area that has shown some results for propane is the certification data. So when we look at certification data, we see that there is some emission benefits for NOx for the recent propane kind of medium heavy-duty engines, but in some cases they have higher emissions. They're still meeting standards, but their emissions can be slightly higher. So why does this potentially happen? Well, propane engines are conversions of gasoline engines, and so what we found is that the deterioration factors, which is basically the way that a lot of manufacturers try to estimate what the emissions are of a vehicle, at 50,000 or 100,000 miles. They don't always just run the engine for 100,000 miles to see what the emissions are at that point. That would take a long time. So what they do is they kind of do some tests to see what happens to the equipment, how does it deteriorate, and then they apply factors. Well, what we have found is that for small volume manufacturers, which are typical of like propane engine vehicle manufacturers, is that their emissions are for deterioration factors are actually higher than those of gasoline. So the OEMs are able to, they have the money, they're able to, do more detailed testing to show that their engines won't deteriorate. But propane often gets just kind of factors from the regulatory agency from sometimes outdated tests. So that's an area that I think is potentially interesting that, that needs more research. That, more detailed deterioration tests could actually show that these propane vehicles actually have lower benefits or lower emissions. The only real in-use testing that we've found, doing research on this has been on some pre-2010 standard propane vehicles and diesel vehicles. So this means they weren't required to reduce NOx significantly, but we still can, hopefully gain a little knowledge from this testing. And so this was school buses. And what it found was that the NOx emissions for propane were actually very, very low compared to diesel. These diesel didn't have SCR, and if they did, we would expect these diesel emissions to be lower. But this result, is still pretty interesting that the propane had, still very low NOx. And then when looking at particulates, these diesel vehicles had, particulate filter, and, in the results for propane, that they're actually still, significantly lower than those with particulate filters. Again, we see this trend of spark-ignited, vehicles with stoichiometric combustion having much higher CO than diesel. Diesel is very low. So I think that, we continue to see that trend. But more work needs to be done in this area to really understand, this, I think, and hopefully, we'll see from that California testing better results. So kind of in conclusion for the heavy-duty vehicles, we've seen that the standards have become increasingly strict. They've required significant improvements in engine controls and after-treatment systems. Alternative fuels have, they're possibly taking advantage of this by having simpler and less costly after-treatment. The emissions may be lower, they might not be, but they don't necessarily need particulate filters or SCR systems, which can add, thousands of dollars to certain, vehicle types. But we have seen some certification benefits for AFVs, but those benefits have diminished, at least on the certification side. There might be relative benefits, it might be 50% lower, but the absolute number is smaller. But more importantly than certification is what are they doing in the real world. So in-use benefits are possible for AFVs, especially if diesel controls or after-treatment don't operate properly. So, and then as I showed with the carbon monoxide concern for spark ignited, alternative fuels may not always be better for every pollutant due to differences in engine types and controls and after-treatment. So California has recently adopted some optional NOx heavy-duty standards to incentivize further reductions. So you can certify at basically, I think 50% lower, 75% lower, or 90% lower than the actual standard. And they've provided some funding through the Carl Moyer program to get grants to actually get these engines out there. And they've been funding work primarily with the natural gas vehicles to see if they can get these very, very low NOx emissions. And they potentially could go to a standard of 0.02 instead of 0.2, and that would push diesels even further. And if the natural gas vehicles are able to meet that standard, that would show a benefit and hopefully increase their sales. Now I'm going to talk a little bit about light-duty gasoline and alternative fuel vehicle emissions. Some recent analysis that we've done on light-duty AFVs and hybrids has shown that they can typically show some emission reductions compared to their gasoline counterparts. It often depends on the model of vehicle, but for compressed natural gas, we can see 20% reduction in NOx, 40% reduction in VOCs, and 25% in CO. E85 vehicles also show some benefits as well. Close to 30% reduction for NOx and CO, and then maybe 5% reduction for VOCs. We have the same kind of issue for propane that we saw for heavy duty, that for NOx and CO they're pretty much the same, maybe a slight increase, and then VOCs are higher for the propane vehicles. I think this similar issues with deterioration factors need to be addressed there. That if the small volume manufacturers of propane light duty cars and trucks can show that their emissions don't deteriorate that fast, we will see that these vehicles have some air pollutant emission benefits. I haven't talked too much about hybrids at all, but wanted to throw that in as well, that hybrids can show emissions reductions as well. Further work is needed to examine like plug-in hybrid electric vehicles. There is some concern in that area related to the the operation of those vehicles, where you might be driving all electrically, where you're only using the battery, and then you might need to accelerate very hard to get on an on-ramp to go to the freeway. And so in some of those vehicle systems, that might turn on the engine. And the concern is that if the after-treatment equipment, like the catalysts, are not warmed up or they're not at the proper temperature, you could have high emissions in those situations. So I think further work needs to be done on that. But looking at certification data, typically the plugins are pretty clean, and they're meeting standards. Obviously, they're out on the road. One of the interesting trends for light-duty vehicles is that really there's been a significant interest in gasoline direct injection vehicles. So the market share of gasoline direct injection has increased from about 4% in 2009 to nearly 40% in 2014. The reason why OEMs are doing gasoline direct injection is that they can use basically smaller engines with turbocharging, and then they can maintain the performance that people want, but also improve fuel economy. The problem with these vehicles is the testing has showed that they can increase the amount of particulate matter, like on a mass basis, so they have more particulate emissions, and they're also increasing the number of fine particulates. So there's big concern there that if we are pushing these vehicles to improve fuel economy, but they might be also causing some health concerns. So there have been some technical solutions brought about to try and maybe address these. So it might need a particulate filter, kind of similar to what is happening with the heavy-duty diesels. So this may provide some opportunity for alternative fuel vehicles or hybrids or plug-ins, potentially at a lower cost, where these vehicles might not need a particulate filter, and so that might reduce the incremental cost. I think that's still something a bit of a question mark, but I think it's an interesting area to think about. So light-duty vehicles, it's similar trends as compared to heavy-duty. The standards have become increasingly strict. It's required significant improvements in engines and controls, and there's really been a push to continue to reduce passenger car and truck emissions. So EPA's Tier 3 standards are being coordinated with California standards as well as some of the greenhouse gas standards. And what these standards are going to do is increase the durability of gasoline and other light-duty vehicles. They're trying to push, again, to make sure that there's not gross emitters. And then by 2017, this rule is going to reduce sulfur content by 2/3, and it's going to reduce NOx, VOCs by about 80%, particulate matter by 70%, and carbon monoxide by 75%. So there's going to be significant amounts of reductions in emissions from new vehicles. Gasoline and alternative fuel vehicles, the same. What potentially, an advantage for alt fuels is that they, may have simpler, less costly after treatment. So, as I mentioned before, the direct injections may require particulate filters. So the stricter standards still pose some challenges for AFVs as well. They have to meet these real strict standards, and it's going to take engineering work to get there. And the regulatory focus is really kind of pushing towards zero-emission vehicles like battery electric, all-electric vehicles, and fuel cell vehicles to try and reduce the air pollutant and other concerns from these vehicles. So California and 9 other states, a lot in the East Coast, have adopted the zero-emission vehicle program to kind of push standards or push vehicles, to be zero-emitting. So in summary, A-Fleet has been using the EPA's MOVES model to estimate the emission certification results to compare alternative fuel vehicle and conventional counterparts. We're updating this based on the latest research that's being done in the area to try to incorporate more in-use testing and understand that situation. EPA's light and heavy-duty standards have become increasingly strict. Both conventional and alternative fuel vehicles have made significant reductions to meet those standards. And what we've seen is alt fuels continue to have some emission benefits. The absolute certification benefits or absolute benefits are smaller than they were in the past. Everything's gotten cleaner. But there still is, some relative benefits. And we also have seen some, testing that has shown that there's in-use emission benefits possibly as well for some alternative fuel vehicles. Future standards will pose, potential opportunities and challenges for AFVs. The potential challenge is to, do the engineering to meet these standards, but the potential, benefits are that they, again, could have less costly after treatment, and they have the ability to get to, zero emissions if you go to, battery electric or fuel cells. So I want to thank Clean Cities for sponsoring some of this work. Some of my colleagues, Hal, Michael, and Marcy from Oregon, and supporting this work as well. So if you guys have any questions, be happy to take any.
Great. Thank you so much, Andy. Can we go ahead and open up the lines for questions, please?
Certainly at this time, if you would like to ask a question, you may do so by pressing star one. Please record your first and last name clearly, as your name is required to introduce the question. To withdraw a question, you may do so by pressing star two. Once again, at this time, if you would like to ask a question, please press star one.
Great, thank you. While we're waiting, again, thank you to Andrew for his presentation today. Some really great information. I do have one question that came in online, Andrew, if you want to go ahead and take that now. The question is, why isn't methane included in vehicle VOCs?
So one of the things I didn't talk too much about was the differences between greenhouse gas emissions and air pollutant emissions. So sometimes, people can get confused as, what is a greenhouse gas emission, what is an air pollutant emission. So methane is really the primary concern for methane CH4 is its impact on climate change, while VOCs or non-methane hydrocarbons, the concern is typically related to its impact on ozone. So it's really just that different chemicals or different pollutants can react differently, and so methane doesn't have major concerns creating ozone, so that's really why it's not included.
Okay, great, thank you. Simone, do we have any questions on the phone line?
There are no questions in queue at this time, but as a reminder, if you would like to ask a question, you may do so by pressing star one. No questions in queue at this time.
Okay, great. Andrew, did you have anything else you wanted to add? Or hold on one second. I see another one online. Let me go ahead and give you this one. Do these measures include well-to-wheel data or just tailpipe emissions? And how would measuring one or the other impact the results?
The focus of the presentation was on the tailpipe emissions. So there is definitely differences between tailpipe and well-to-wheel. So well-to-wheel or life cycle emissions tries to account for the emissions from all the sources related to producing a fuel, transporting the fuel to get to your vehicle. So let's say for natural gas, you have to drill a well, you pump it out, there's some transmission through pipelines and processing. Through that process, you want to calculate all the emissions of all the equipment required to get that natural gas into your car. Here, what I was talking about is really the emissions coming from the tailpipe. And the real reason why, the focus is on tailpipe emissions is, for vehicle emissions, air pollutant emissions, you're primarily concerned with exposure to humans and the public in general. So, that typically happens in urban areas, and the emissions happen, kind of where you are. When you look at the life cycle, a lot of the emissions can be shifted to areas, 10 miles, 100 miles, maybe 1,000 miles away, because, they don't all happen in the same place. You could be getting, say, oil from, internationally from the Middle East or something like that. So it's just, it's basically kind of the question you want to answer, how do these emissions impact health in my area? So when you're trying to address that question, you really want to look at vehicle emissions, and then, you might want to look at if there's any other sources of emissions elsewhere that contribute, like refineries or things like that, that might also impact. So that's kind of the difference.
We have a question in queue.
All right, go ahead.
Steve Russell, your line is open, sir.
Great. I recently, Heavy Duty Trucking has just released a study on clean diesel exhaust, safe for animal lungs, probably human. And they lead off by saying modern diesels burn so cleanly that laboratory rats suffered no lung illnesses during a lengthy study of their exposure to exhaust gases, according to the Health Effects Institute, which is releasing a report today. I'm not sure I believe this, but it is coming from the diesel industry, trucking industry. In response to that?
I haven't seen that study, so I can't responded to it directly, but I think what the recent testing has shown that diesel vehicles can operate very cleanly if everything's going, as planned, basically. If the SCR is working as it should, if the particulate filters are acting as it should, the emissions should be very low. The concern is that, those things, can fail. SCR requires, an operator to actually put SCR, this diesel exhaust fluid on the vehicle. And then it requires, some of the particulate filters can require maintenance and things like that. So there's just concern with, when they're not operating correctly. And so that's probably, would be my takeaway from, trying to address that.
The other concern I have is that, there are many, many, many older vehicles on the road today. The percentage of new vehicles is very small, so we're still being exposed to amazing amounts of pollutants because people just aren't buying the new trucks.
Yeah.
Fair assumption?
Yeah, that's an important thing, and so I talk about that when I discuss A-Fleet in general, is that, the biggest bang for your buck to improve emissions from vehicles is to get the oldest, dirtiest, vehicles off the road. And so, that can be done in different ways, but, getting those older vehicles that, are, again, dirty, or, if you're doing some inspection and maintenance program to try and find the gross emitters, that's also an effective way to reduce emissions. And then what we've seen is that, alternative fuel vehicles, have the ability to, potentially have better emissions in situations where, say diesel might not be operating, the exact way it should be. SCR fails or particulate filter fails. Because some of the equipment is simpler, it doesn't need the maintenance. You have, a more guaranteed chance that, the emissions are going to be low from those vehicles. And so California has really been pushing, the NOx standards and have been funding development of natural gas vehicles to try and meet those standards. They really want to see, heavy-duty vehicles be extremely low emissions, and they call it basically having power plant level emissions, so reducing the emissions to such a low level that they're basically equivalent to a natural gas power plant. So, there's been a lot of focus on that, and so I think that's an interesting area to look at.
Great. Thank you.
Again, as a reminder, if you would like to ask a question, you may do so at this time by pressing star 1.
All right. Thank you. We have another question that came in online, Andrew. Are there measurements of in-use PM 2.5 emissions from heavy-duty CNG?
Yes, we do have that. I didn't present those results. They're very low. I think the Argonne's developing a report on that, and I think they're, in the same ballpark. I'd have to kind of pull up the numbers, but if whoever asked that question wants to see that, I can send them some tables or references to show them what the numbers are, but they're at least equivalent or lower than diesel.
Great, thank you. Someone, any other questions on the phone?
Currently at this time, there are no questions in queue.
Okay. We're about 2 minutes from the top of the hour. Andy or Andrew, I don't know if you had any additional or final thoughts. And then just as a reminder, we will be posting the recording and the PowerPoint. Oh, I see another question coming in on the Clean Cities webinar archives pages, so look for that. Let me go ahead and give you this question. You mentioned biodiesel not having higher or lower NOx emissions when compared to regular diesel. Do you mind letting us know when the study was done? Seems like they've been getting some back and forth in their area at the state level.
So we've looked at two different studies on this. One was a study of buses, and it was basically they tested European vehicles in in the 2002 time frame, and then in the U.S. they tested U.S. vehicles. So I presented the U.S. vehicle results, and those included, the 2010 emission standard vehicles. So they are the most recent vehicle, type. So, and then there's been some studies by NREL actually, has looked at this as well, and they've seen, there is some variance, but they've, basically concluded that there's really no, significant difference between, B20 and diesel for NOx emissions. So if that person wants to, follow up with me, I can send them the studies, but those were also, post-2010 engines that NREL tested.
Okay, great. Another question. If measuring only from the tailpipe, how would a study compare emissions of BEVs and PHEVs against legacy and other alternative fuel types?
Yeah, that's a really good question. And I think, these types of emission factors and what a fleet can do is, give you a sense of what emissions might be. If you are in a metropolitan planning organization or some area that's, focusing on the air pollutant emissions in the region, you have to develop inventories. You have to kind of take it to the next step. You say, what are the emissions from the vehicles, and you might want to look at the other sources, where are the power plants in our area. So it would require, some further study. We do have in the GREEP model, which, I think Sandra talked about that we work on here, is we do have some comparisons of the upstream versus the vehicle level emissions. So you can use that to get a relative sense of, which one's higher, which one's lower, and then depending on, what power plants are in your area and things like that, you could potentially do an analysis that way.
Okay, great. Any additional phone questions?
There are no questions in queue at this time.
There's, I think Sandra is sending out the slides. Some of the backup slides kind of talk about the EPA's National Ambient Air Quality Standards, and one recent development is that they have proposed to reduce the ozone levels that are allowed. And so that's something that's going to, kind of part of why light-duty vehicles emission standards are getting, lower, because they're trying to meet those standards. So there's a couple backup slides that are, kind of talk about what areas are in non-attainment and what EPA, projects for that. So people are interested in that. Those are in the backup slides as well.
Great. Well, thank you for including those. And if anyone wants to reach out to Andrew, his email is there. It's aburnham@anl.gov. You can also reach out to myself, Sandra Loy. And I guess we'll go ahead and wrap up for today. Thank you, Andrew, for your presentation. Again, really great information. Thank you for sharing with all of us. And as I mentioned, it will be available on the Clean Cities webinar archives pages. And don't hesitate to reach out if you have any additional questions later on. And again, thank you, everyone, for joining us today.
This now concludes today's meeting. All lines, please disconnect.